Okay. So wholes. Wholes means they can be obtained by where there are common linear factors in numerator and denominator. This is the simplest definition. Okay. So let's say f of x is equal to rational function 9x cube plus 63x square upon x square plus 7 x plus 7. So what are the wholes?
The wholes would be the whole is at x plus 7, or when x is negative 7.
X is equal to negative 7 wholes are there. Okay. So we have cancelled a linear factor. So let's say f of x is equal to 5x square plus 10 upon x square plus x square x cube plus x square plus 2x plus 2. What about this?
It's at when x is equal to plus or minus root 2.
Okay, in the numerator, it is 5 into x square plus 2, right?
Yeah, and then in the denominator, you factor out x squared from the first two, so it becomes x squared times x plus 1, or it becomes x squared plus 2 times x plus 1.
Yeah, x square plus 2 into x plus 1, right? So,
Yeah.
notice something.
Yeah.
This value, you have cancelled, correct?
Yeah.
See, this x square plus 2 can never be 0. Do you agree or disagree?
Yeah.
For x is equal to real. So what we have cancelled is a real number, not a non-zero number, not a zero number.
Oh, so there's no whole.
So there is no whole. Okay, that is the thing. So this will be 5 upon x plus 1. Okay, so this is the main concept. Let's try this one. Let's say f of x is equal to 9x4 over 4 72x, like this. Same question, find the wholes.
Does that say 21 at the bottom?
Where?
Like, does that say
2.
x squared minus 2? There's no whole.
Okay, let's try it. So numerator becomes what if you factorize?
9x times x cubed plus 8
Over
x minus 1 squared.
x minus 1 square. Is it like this?
X plus 2 x minus 1.
X minus 1 x plus 2, correct?
Yeah.
What now? Can you simplify further?
Yeah, you could simplify the x cubed plus 8 into x minus 2, or x plus 2 times x squared minus 2a.
2?
I mean 2x
Hmm.
plus 4.
Good.
Or minus 4. Or plus 4. Yeah, plus 4.
See, a plus b into a square minus ab plus b square. A cube plus b cube. A cube minus b cube means, so you flip wherever there is b, negative b. So a minus b, a square plus ab minus b square means plus b square, like this.
Yeah.
Okay, anyways, so whole is at negative 2. And yeah, one small thing is, so 9x into x square minus 2x plus 4 upon x minus
X
1.
minus 1.
So, so whenever in this formula, if you see this discriminant, if you observe the discriminant for this quadratic, is it positive or negative?
It's negative.
Negative, right? So that means
Yeah.
it will not be 0.
Not be 0.
Will never be 0. Okay. So even if you get any additional factor in the denominator, if you cancel it, no need to worry about wholes. Okay. So that is the main thing. So you can cancel it as it is. So these are some applications of knowledge. Next is horizontal asymptote, vertical asymptotes are clear, right?
Yeah. Vertical
Horizontal-
asymptote is what's in the denominator.
Yeah.
Like what makes it 0.
Horizontal asymptote is when x is infinite. So I write it like this: HIVD. High VD, like video. So high means infinite, x stands for infinite, plus minus infinite.
Mm-hmm.
V means vertical asymptote means denominator 0. To get vertical asymptotes, horizontal asymptotes is for plus or minus infinite. Yeah. So that is about holes, vertical asymptotes, horizontal asymptotes. 1.8, 1.9. What is 1.10? Okay, that is also 1.10. Yeah, so 1.11 is equivalent forms. Equivalent forms means, generally in quadratics, you might have heard there are 3 forms. One is general, second one is
In quadratic? Standard form?
standard or general, it is the same word.
Oh, okay. Like factored?
Factored.
And there's a third one?
Vertex.
Oh, yeah, vertex form.
So basically these are the different forms, right? So same quadratic expression, let's say x square minus 5x plus 6 can be expressed in standard form, can be expressed in factored form, can be expressed in vertex form. So that is what it means by equivalent forms. So from one form to other, that is the same thing. Simple, right?
Yeah.
Yeah. And what's useful is factored form. Factored form is when you use long division or synthetic division to find linear factors, and then for higher order expressions like this, you write x plus 1 into x squared plus 2x plus 1, right? So this is factored form, equivalent expression of cubic. So that is the idea. Let's talk about domain and range. Let's talk about 2 cases, domain and range, for when a rational function, yeah,
Yeah.
when a rational function is in the form of linear upon linear, let's say ax plus b upon cx plus d. Okay. Domain is R minus element d by c, negative d by c. Any doubt?
What does R stand for?
Real numbers except element d, negative d by c. Yeah, so that is about domain. That is fun. Range means in this form, linear upon linear form, all reals except
the
a upon
wholes
c.
and oh wait, this is for rational function?
Yes, in the form of linear upon linear form. Linear in the numerator, linear in the denominator. So it's like if they give you example, f of x is equal to 5x plus 6 upon 9x plus 1. What is the domain and what is the range? To get the instant answer, we can use the concept. What is the domain? Tell me.
All real numbers except for x cannot be negative 1/9.
Next, domain and range.
The range is all real numbers except x cannot be 5/9.
That's it. This is a shortcut. Okay. So,
yeah.
And what is the range of x square?
The range of x squared? Y is greater than or equal to 0.
Yeah, greater than or equal to 0. What about x minus 1 whole square?
So x minus 1?
Like this. For this, what is the range?
Y is greater than or equal to 0.
Still same.
Yeah.
What about like this?
Y is greater than or equal to 1.
What about, let's say, 2 times of x minus 1 whole square plus 1?
Y is greater than or equal to 1.
Still 1, right?
Yeah.
So this is about quadratics, domain and range. And what is the domain for polynomial functions?
All real numbers?
Yes, polynomials, correct?
Yeah.
Polynomials is equal to real numbers. That is an automatical. Unless the domain is restricted. Let's say we talk about certain interval, we can assume that domain can be real numbers. So unless interval is specifically restricted. Okay.
Yeah.
So that's about some basics. See, chapter 1 is about combination of algebra 2 concepts.
Yeah.
So let's move on to 1.12. Transformations. Are you familiar with this topic, Alexa?
A little bit.
Okay. Okay. Transformations of functions, right?
Yeah.
Let's understand how quadratic transformation works. Let's say y is equal to x square. Can you draw it? Quick. Yes. So a value is 1, right?
Yeah.
What if y is equal to 2x square?
Like it goes in more?
Yeah, I mean, keep that a equal to 1 for reference.
Okay. This is the regular one, and then this is the 2x.
So it shrinks, right? Compresses.
Yeah.
So vertically it has been compressed. So this is a for a equal to 2. What about a equal to 3?
It would be even smaller.
Even smaller. So basically a greater than 1 means vertical compression.
Vertical, there's that vertical stretch and horizontal compression.
Yeah, horizontal compression, vertical stretch.
Yeah.
Yes, correct. Hmm. So what if a is less than 1? Let's say 0.5. Y equal to 1 by 3 or 1 by 2 x square.
Then it becomes wider.
Wider, right? So I'm writing here a is less than 1. Okay.
Yeah.
So what if a is negative 1 this time? Y is equal to, let's say, negative x square.
It gets reflected across the x-axis.
Yes. So it will be symmetric to which of the following above?
Y equals x squared.
Correct. And what if, let's say, y is equal to negative 0.5 x square?
It's symmetric to y is equal to 0.5 x squared.
So in the bottom, graph gets wider when
When a is in between 0 and 1.
yeah, a is less than 0, still it is also greater than negative 1.
Oh, okay. Yeah.
See, in the top, graph gets wider when a is greater than 1, right?
Yeah.
See, there is a pattern to remember this. If you reflect it, a becomes negative a, right?
Yeah.
So this inequality becomes a becomes negative a. So negative a less than negative 1. If you multiply by negative sign, okay,
Yeah.
this flips. So basically, negative a means what? Down we already know that a value will be negative. So we just write a is also negative. So from negative 1 to 0. That is the way. You can remember that. Okay.
Mm.
And when it gets compressed like this, it will be obviously a less than negative 1. Okay. In the top, when it is compressed, a greater than 1, right? Okay. Okay, scroll down. I'll try to write from the beginning. This is for a is equal to 1. This is for when a value is greater than 1. And this is for a less than 1. Any doubt?
No.
So if you draw a graph symmetric to this red one, like this, it will be negative 1, correct?
Yeah.
Not this one, but this purple one, same color. A will be negative 1. Okay. Next, if you draw symmetric to red, it will be
Yeah, so when a is less than negative 1.
less than negative 1. Yeah.
And then the final one is when it's in between 0 and negative 1.
Yeah. And a is less than 1, right? In the beginning, a is also greater than 0. So this, if you flip, 0 becomes greater than negative a, becomes greater than negative 1. So between negative 1 and 0. That's it. So if you can just directly check it. If question comes, let's say y is equal to 0.15 x square. you can identify in which value, in which range the a value is, and then you can directly choose the graph, whether it gets compressed or stretched. That's it.
Mhm.
So similarly, it is the same thing in functions also. Let's talk about translations first in functions, polynomial functions or whatever. Okay, let's say f of x is equal to x square. What will be the graph of f of x minus 1? Like this,
It'll shift over to the right.
right side, right?
Yeah.
So f of x minus 1, this is. What if if I add another number, x minus 1, let's say plus 1.
It'll be moved over to the right one, and then it'll go up by 1.
Okay, so right 1 and then 1. Here 1, and then this is also 1 unit.
Yeah.
So graph starts from here like this. I mean, that's it. So that is about horizontal and vertical translation. Now let's talk about dilations. Dilations means this time a times of some f of x. So I'll give you a table. So it's like formulas. Hmm. Okay. Okay, before that, let's talk about reflections also. If f of x becomes f of negative x, what will be the change?
No.
X becomes negative x, right?
Oh, so then that's a reflection across the y-axis?
If x changes to negative x, this reflection across
Y-axis.
y-axis. Similarly, can you guess if f of x changes to f of negative f of x?
Then that's reflection across x-axis.
X-axis. So translation, reflection. Now let's talk about dilations, the topic above. So write this table. I'll write it here. It's the same like uh, it's the same scenario when we discussed about quadratics. So when absolute value of a is less than 1, the graph gets vertically compressed. Yeah. Mm, and when absolute value of a is greater than 1, vertical stretch.
Stretch.
And when a is less than 0, the graph reflects also, right?
Yeah.
So reflection plus dilation, both happens. Dilation means depending on if a is negative 0.5, graph will be something. If a is negative 2, graph will be something.
Yeah.
This is a greater than negative 1 case. This is a less than negative 2, negative 1 case. So you have to perform reflection and dilation. So it's the same thing. When a is 0.5 in the quadratic graph above, when a is 0.5, the graph was vertically compressed. Same thing.
Yeah.
So this is valid for all other polynomial functions. Okay.
Yeah.
Even and odd functions, I think you know. So even and odd functions help you to determine if the graph is symmetric about x-axis or y-axis. Let's say f of x is equal to 6x cubed sin x plus x power 4. Determine if the function is even, odd, or neither even nor odd. Which one is that?
Sine is an odd function, right?
Yes, sin is odd function.
So if you plug in negative x, it would become
So yeah, if you plug it,
x cubed times sine x plus x to the fourth. But then if you plug in, and then if you make it minus, then it becomes minus 6x cubed sine x minus x minus 4. So is it an even function?
yeah, this is an even function, right? So positive 6x cubed sin x plus x power 4. So overall it is even. I think you know even into odd is odd, odd into even into even, odd into odd. Correct?
Yeah.
So, but what if even plus even? Is it even? Always, sometimes, never. Which one is it answer?
Always.
Okay, yeah, always. What about odd plus odd?
Odd plus odd is even.
Odd plus odd. Okay, let's say if I take one function is x, if another function is negative x, odd plus odd will be
0.
0. So is it an even function?
No. So it's an odd function.
See, f of x 0 means what? If you put negative x also,
Oh.
still 0 is equal to f of x, even function.
Oh yeah.
So even is possible, odd is also possible. So always, sometimes, never means if I say odd plus odd is odd, this is sometimes.
Yeah.
So that is the key difference. Even plus even is even, odd plus odd is odd. Even into odd into odd. Those 4 cases we already discussed. So, so that is about reflection, dilations, rotation. Okay. Okay, let's say the graph of a function is given.
The graph of the function's what?
Is given like this.
Mm-hmm.
This is 1, this is 2, 3. So this is y is equal to f of x. Draw the graph of g of x, which is negative of f of x minus 3 minus 3.
F of. So you would have to move everything to the right by 3, and then move everything down by 3.
And is that all?
Oh, and make it symmetric across the x-axis.
Okay. So yeah. So draw it.
I'll draw it again.
Yeah.
From this graph, or should I draw a new one?
I mean, you can draw it on this also, on the same graph.
So it has to go down. So you reflect it over the x-axis, and so then the original point would be here,
Yeah.
like here. But since you're going down by 3, then you have to go down to here, and then it has to be moved over by 3. So
Yeah.
it's moved over to here, which is like around 4. Or I tried to do it around 4.
Yeah, that's it. That is correct. One, the shortcut is actually you mark this critical points. This is the sharp edges. Let's say you consider this 4 points, and you should just perform translation for this,
To those points, yeah.
and then join those points. So you can just mark A, B, C, D. Find
And then A prime, B prime, C prime.
good. A dash, B dash, C dash, D dash. Join to get graph. So instead of focusing on the entire graph, it's like that. So let's go to the page number 2. So let me erase this.
Yeah, I'm at the top.
Yeah. Okay. Okay, so far we have understood how to draw the graph when we reflect it, when we translate it horizontally and vertically. But when the graph dilates, it's important to draw a precise curve, precise diagram of the graph. So there are certain things which we need to keep in mind. So let's study about dilation for a bit. Horizontal dilation and vertical dilation separately. So horizontal dilation means, let's say f of x becomes 2x, or f of x becomes 0.5x, or x by 2, x by 3, x by 9, whatever.
Mm-hmm.
So the factor, so by how much it is being dilated, by how much factor it is being dilated, this factor formula is actually whatever the coefficient of x you see, you flip that
2.
reciprocal.
Also 1/2.
So 1/2, is it greater than or less than 1?
Less than 1.
Less than 1. So that means the graph undergoes horizontally compression. Okay,
Yeah.
this is the method.
So you just take the reciprocal of whatever the coefficient is.
Coefficient of x. Let's say f of x becomes, so horizontally before horizontally compressed by a factor of half.
Of f. Oh, half.
1 by 2. Correct? This.
Yeah.
So let's say f of x becomes x by 9. F of x by 9. What happens? Can you guess?
So it becomes 1. It becomes 9.
9. So it is greater than 1.
1. So we got vertically stretched.
See,
Or
effect is on
horizontally.
x, right? X effect means horizontal effects.
Yeah, so horizontally stretched.
Simple. Stretched by how many fold? How much fold?
By 9.
9 folds or 9 by a factor of 9. It's the same thing, right?
Yeah.
So this is the shortcut. Okay. But for y, let's say vertical dilation. It's quite obvious. Vertical dilation actually we've been studying just now. F of x becomes a times of f of x. Let's say becomes a times of f of x. Correct?
Yeah.
So we discussed 3 cases. Absolute value of a greater than 1 means compressed. Vertically compressed.
Yeah, vertically compressed. And then if it's if absolute value of a is greater than 1, then it's vertically stretched.
Okay.
Oh wait, no, it's compressed. Yeah.
Like vertically. Okay. Yeah.
Yeah.
Stretch and compressed.
Yeah.
So that's it. So for y, it is obvious. So for x, if x becomes let's say 2x, it's not obvious. It will not be twofold. It's the opposite.
So it's 1/2.
1/2. Reciprocal. So you can remember it like this. X means in English you write opposite, right? Synonym, antonyms. So for y, simple. But in translations also, when you write x becomes x minus 1, it goes 1 unit right side. Counterintuitive, right?
Yeah.
But f of x becomes f of x plus 1 means
F of x plus 1, it goes up 1.
up, right? So for y values, it's pretty obvious. X value is counterintuitive.
Yeah.
So with regards to translation or dilation, so x is counterintuitive. So it's like opposite to our intuition.
Yeah.
Okay. Now, so to summarize everything, if I write y is equal to f of x becomes y is equal to some a times of x plus b times of x plus h plus k. What is happening exactly? How do you transform this?
So the a outside of f is what's vertically happening. The b is the horizontal change. The h is the left or right change, and then the k is up or down change. And then h comma k is the vertex.
So I'll tell you one trick. So obviously the transformation undergoes step by step. Step number 1 is left going left. Step number 2 is multiplication, dilation, things like that. There is an order to follow, right?
Yeah.
So which one to do? Whether I should add this first or whether I should dilate this first, which one to do?
Shouldn't you start with the left or right change first?
What we need to do is we need to focus on this inside thing. You slowly come out. So first x becomes x plus h, horizontal transformation, and then horizontal dilation because of b, and then vertical dilation, and then
vertical translation.
yeah, that is the way. So come from inside to outside. That is the order. What to perform first? Like, is it dilation, reflection, or translation? That's odd.
Yeah. You do translation first.
Okay, let me delete the page number 3. Seems like character limit has been reached. Hold on a second. Okay. So the concept is come from in, then out. So tell me the first step, what will happen?
You do the translation left or right first.
Oh, yeah, so
And then you do horizontal dilation.
horizontal translation, I'm writing T. So 1 by a factor, right? Okay, 1 by what is it? What factor is it? B.
Oh, don't you? Yeah, B.
1 by B.
So like the horizontal.
1 by B.
Is
Horizontal dilation. Okay.
horizontal dilation.
So depending on B value,
And then
whether this factor
you
will be
do
less or
vertical
more.
dilation.
Yeah. Next, what happens?
You do 1 over A. Or is it just A?
For Y, it is pretty
The
obvious.
absolute value of A factor is vertical dilation.
Yeah, vertical dilation. Yeah. Next,
And then you do vertical translation.
K units, vertical translation. Okay. So now let's do one question. So this is the order. Okay. I think you understood it. Uh, let's say y is equal to f of x is given. How will the graph change when y is equal to, let's say, -2 f of 2x plus 1, or let's say 9x plus 1 minus square? What is the steps to perform this transformation?
First you move to the left by 1.
Yeah. So f of x is
You go
moved.
to the left by 1.
Oh, see, it is not 1. Can you guess why?
You go to the left, so it's -1.
What you need to do is you have to take 9
Oh,
common.
no. You make it, yeah, you have to make it 0. So you move to the left by -1/9.
So x plus 1 by 9, right? So
Yeah.
step number 1 is left by 1 by 9 units.
Yeah.
Okay. Step number 2.
And then you do the the vertical dilation by -2.
See, you have moved left. Slowly come outside. What is happening?
So you do the -2.
Did you miss this? 9.
Oh, so then you multiply the 9.
So what is the factor?
1/9.
1/9 fold horizontal. Is it compression or stretch?
Oh, it's horizontal stretch.
See, 1/9 is less than 1. So compression.
Oh, so horizontal compression.
So horizontal compression by a factor of 1/9 factor. What is the next step? Slowly come out, inside to outside.
And now you do vertical by -2.
By -2 means what?
You reflect it over the x-axis,
So
and then it's vertically stretched by 2.
yeah, vertical dilation and reflection. Dilation plus reflection means reflection across which axis?
The x-axis.
Good. F of x becomes negative f of x. Y becomes negative y means reflection across x-axis. So dilation. What is the factor for dilation?
It's just 2.
2 or 1/2. Which one is it?
2.
2, right? Vertical dilation by 2-fold or factor of 2. Same thing.
Yeah. And then you go down by 5.
Okay, when we did multiplication by 2, dilation by 2, there is one more thing. Can you guess? In between.
I don't know.
I mean, it's not 2, right? It is -2, correct?
Yeah, so you reflect it over the x-axis. I thought we already did that.
Okay, I have not written that. Okay, anyways.
Oh,
So
okay.
reflection.
Yeah, I thought you wrote it up there.
Okay. Yeah, reflection. What is the last step in the process?
You go down by 5.
Down by 5 units. So this is the process. Okay. Okay, you see this point number 4? Is it visible?
Yeah, I can see it.
Okay, okay. So we'll move to the sketch. Light roll. Okay. So transformations is a bit complicated, but if you follow this standard operating procedures, questions will be easy. Okay. Now, I'm not sure if it is in the syllabus. I mean, what I taught was in the syllabus. What I'm about to teach, I'm thinking whether it is in the syllabus or not. I think. Okay, I think it should be technically. So let's consider the previous example. Domain of f of x is given as, let's say, 8 to 14. Sorry. Range is -9 to 3. G of x is given as -3 times of f of 9 times of x plus 2 minus pi.
Yeah.
What is the domain and range of g of x? Domain and range of g of x.
Wouldn't the domain be all real numbers? And then for the range, you define like the vertex.
Domain of g
So the
means
domain is, yeah, the domain is all real numbers, and then the range is x is less than or equal to -5, or y is less than or equal to -5.
we know domain range of f of x. We know domain of f of x also. That is given. So we cannot just randomly put all real numbers here, right? Because f has a restriction that its domain should lie between 8 to 14. Whatever the numbers you put, the number should lie between 8 to 14.
Oh, so then the domain is just from 8 to 14.
Yes. So 9 times of x plus 2 should lie between like this, correct?
14.
So this gives us domain values. Any doubt?
No.
So you can solve this to get domain. And regarding range, can you guess what is the range? How to do this?
You plug in the domain values, like the lowest and highest.
See, which domain values you put, the answer which you are going to obtain from here, right? Those values only you are going to put here, correct? For x.
Yeah.
So no need to worry about what we are going to put. So treat this as f of x only. Whatever the values you are going to put, this range will be 8 to 14, correct?
Yeah.
So expression inside x, f of x, inside of f of this,
It would be the simplified from the domain.
yes, vary from 8 to 14 only.
Oh, yeah.
So treat it as, treat as f of x only. Simple, right?
Yeah.
So it's the same as domain of range of finding negative 3 fx minus pi, like this. So
Yeah.
range of g is same as range of the above value. Any doubt so far?
No.
So can you find that range now?
Wait, but like the range of f?
Range of g. Range of g of x when f is given.
F is given as f of x. So then wouldn't it just be y is less than or equal to 5, negative 5?
I mean, it is multiplied by negative 3 also, right?
Yeah.
See,
But that's just vertical.
Yeah, vertical dilation undergoes, right?
Yeah, so then it becomes y is less than or equal to negative 5.
Well, not quite, but let us try to understand. The range of f is given as what? Look at the question.
F of x.
Yeah, range of f. Output values of f of x varies from which to which?
8 to 14.
See, that is x value, domain that is. I'm talking about range, output values.
Isn't it just f of x? Because we never solved for it.
Yeah, it is given in the question. What is the range of f of x?
Minus 3 times f of x minus 5.
See, in the first line of the question, range of f of x is given as this one.
Oh, negative 9 and 3.
See, this is domain, okay? Domain of f. This is range of f. So f values, output values of f vary from negative 9 to 3.
Yeah.
Okay. So how will that affect g? G of x range, how do you find that?
Negative 9 is less than or equal to negative 3. F of x minus 5 is less than or equal to 3.
See, if you study the g of x carefully, what is happening is f of x is being multiplied by -3 first.
Yeah.
And then for that answer, you are subtracting -5. So y values,
Yeah.
you cannot just write like y is less than or equal to 5. That is not the case. What is happening is you can write like this. So -3 multiplied by the range, which is -9 to 3 minus 5. This is the domain. This is the range of G.
Okay.
So this is a bit tricky, but so if you multiply -3 to this range, what happens? Can you tell me? What is the interval?
27, -9 to 27.
Yes, -9 to +27. Correct. Okay, let's say this was 2 here. That will be convenient. What happens now? This is the range. -9 to 2.
6. Yeah, -6 to 27.
-6 to +27 is the range. And then we have to subtract by 5 also, correct?
Yeah.
So
it
minimum value is
becomes -11.
yeah,
-11 and 22.
22. So minimum value gets subtracted by 5. Maximum value also gets subtracted by 5. Okay.
Yeah.
So this is the final range of g of x. Okay. Any doubts so far?
No.
So these are some like complex operations like multi-step layer questions. I mean, I don't know if questions will be after this much of uh, this difficulty, but it's good to understand the concept. Fine.
Yeah.
I mean, if you understand this, questions below that will be obviously easy. Makes sense, right?